I want you to imagine a plague, but not a biological one. No viruses, no bacteria, nothing you can vaccinate against. Imagine a plague that doesn't attack your cells, but your atoms. Everything around you right now, your screen, your hands, the air you breathe, is made of normal matter. Atoms, protons, neutrons. It's a perfect stable system, or so we think. But there is a theory, one that has kept physicists awake at night for decades. It suggests that our matter isn't actually the true form of the universe, that we are all effectively living on thin ice, because out there, a substance might exist that is more real than we are, a substance that destroys everything it touches. No, actually, it's worse than destruction. It converts it. A single drop of this stuff on Earth, and within hours, our entire planet would be nothing but a hot, dead ball of strange slime. This isn't science fiction. This is the physics of strange matter. And it might be the most dangerous thing in the universe. Chapter 1. The Universe's Pressure Cooker. To understand why this stuff is so terrifying, we have to travel to where physics starts to break down. The most violent places in the cosmos. Neutron stars. Neutron stars are the corpses of massive suns. When a star dies and explodes as a supernova, sometimes a core is left behind. This core is tiny, maybe 20 kilometers wide, the size of a city, but it weighs more than our sun. Imagine taking the entire human race, all 8 billion of us, and squishing us together until we fit inside a single sugar cube. That is the kind of density we're talking about. Down here, the pressure is so intense that the rules of everyday life stop existing. In a normal atom, there's a lot of empty space between the nucleus and the electrons. But here, the pressure violently crushes the electrons into the protons. Everything becomes neutrons. There is no empty space left. But deep in the core, where the pressure gets even more insane, something even more radical happens. The neutrons themselves dissolve. Usually, quarks, the building blocks of matter, are like inseparable twins. You never find them alone. There are up quarks and down quarks. That's what we are made of. But in the core of a neutron star, the party is over. The pressure is so high that the quarks are set free. They swim around in a kind of quark soup. And it is here in this physical cauldron that some quarks change. They become heavier, stranger. They turn into strange quarks. And that is where the horror begins. Before we stare deeper into the abyss, if you're enjoying the existential dread so far and want to learn more about the universe's dark secrets, please take a second to like the video and subscribe to the channel. It helps me out a ton. Thank you. Now, back into the quark soup. Chapter 2. The Bodmer-Witten Hypothesis. Why it happens. Now you might be asking, okay, some weird particles inside a dead star? Who cares? The problem is stability. The universe is lazy. Everything always wants to be in the lowest possible energy state. A ball rolls down a hill until it hits the bottom. It doesn't just hang out in the middle. Our normal matter, protons and neutrons, sits at the bottom of the valley. We always thought we were in the most stable state. We thought we were at the bottom. But in the 80s, physicists like Edward Witten proposed a disturbing hypothesis. What if we aren't at the bottom? What if there is a deeper valley? The theory suggests that a mixture of up, down, and strange quarks, strange matter, might be more stable than anything else. It would be the perfect state of matter, the true ground floor of the universe. And that is a death sentence for normal matter. Because if strange matter is better and more stable than us, then the universe wants to become strange matter. Chapter 3. The Midas touch, infection, and the moon argument. Think of strange matter as the ultimate peer pressure. If a lump of it, called a strangelet, comes into contact with normal matter, you don't get an explosion in the classical sense. You get a conversion. The strange matter touches a normal atom and effectively tells it, hey, my energy state is way more relaxed than yours. Join us. And because physics rewards laziness, the normal atom agrees. It dissolves, rearranges its quarks, and becomes strange matter itself. This releases energy, a lot of energy. The whole thing works like the Midas touch from Greek mythology. Everything King Midas touched turned to gold. But here, everything turns into gray, hot quark soup. This is actually the exact reason why, back in 2008, there was a brief media panic when they turned on the Large Hadron Collider, LHC. People were genuinely afraid we might accidentally create strangelets in the lab and delete the Earth. But physicists stayed calm. Why? Because of the moon argument. The moon has no atmosphere and has been bombarded by cosmic rays for billions of years. Rays much more energetic than anything we can do in the LHC. If these collisions could create stable strangelets, the moon would have turned into a ball of strange matter eons ago. Since it's still shining up there and not a lump of strange sludge, we know high-energy collisions alone aren't enough to kill us. Chapter 4, the scenario, gray goo. But collisions aren't the only source. Neutron stars collide sometimes. When they do, they spew material directly from their cores out into space. We aren't talking about tiny particles from a lab here, but macroscopic chunks of strange matter flying through the void like cosmic mines. Let's say one of these strangelets hits Earth today. We wouldn't even see it coming. It wouldn't bounce off the atmosphere. It is so heavy and dense that it would fall through rock like a hot steel ball falling through butter. It would plummet straight toward the Earth's core. On its way down, it starts to eat. It converts the rock around it. As it does, it grows, and the bigger it gets, the more normal matter it touches. The reaction accelerates exponentially. The Earth would start to glow from the inside out, but not like lava. Strange matter is hotter. Within hours or days, the crust would become unstable. Massive earthquakes would tear the planet apart as the core collapses. Because strange matter takes up way less space than normal matter, the Earth would shrink. In the end, there is no blue planet. No oceans, no atmosphere, just a hot, clumpy ball the size of an asteroid. A giant strangelet. All of history, all of life, just reformatted. Conclusion, the scientific shield. Okay, before you start building a bunker, take a breath. Besides the moon argument, there are two other physical reasons why we are probably safe. These are the details disaster movies usually leave out. First, the Coulomb barrier. Strangelets are likely positively charged, just like the nuclei of our atoms. Since like charges repel, think of two magnets pushing each other away. A strangelet might not even be able to touch our matter. It would be repelled electromagnetically before the deadly infection could even begin. Second, stability. Just like a drop of water needs a certain size not to evaporate immediately, strangelets likely need a minimum size. Physicists suspect that small strangelets are unstable and would decay instantly in space. Only gigantic chunks would be dangerous, and the odds of getting hit by one are astronomically low. Maybe there are strange stars out there, stars that have already been fully converted, but as long as they don't come visit us, we're good. Strange matter is one of those concepts that shows us how little we actually know. We build our world on the belief that the ground beneath us is solid, but in quantum physics, solid is just an illusion. What do you think? Is strange matter real or just a mathematical ghost? Let me know in the comments. And don't forget to subscribe before the strangelets get us. Stay curious.